Hi everyone, in this video tutorial I'm going to be going over the first fundamental part of calculus, which are limits. So what exactly is a limit? A limit is a certain point in a function that reaches in a domain with its range. So for example, let's say you have a graph and a function. Let's say that function is f of x is equal to x squared. So what exactly is the function x squared? So it would look, you already know, it's a parabolic function that looks something like this. Keep in mind this is not drawn to scale. Let's say we have 1 and 2, and then 1, 2, 3, and then 4, then 5. So we already know what f of x looks like, x squared looks like. So let's go over an example. The limits are derived by this notation, are represented by this notation. The limit as x approaches, let's say, 2 of f of x. So x can approach any value. Likewise, if you're doing multivariable calculus later, it will be approaching multiple values. But in this case, we're only going to be going over the single value of a limit. So as we can plug f of x into the placeholder, which is x squared. So it would be the limit as x approaches 2 of x squared. So it's pretty straightforward. All you need to do next is plug in 2 into the placeholder of x. So it would be 2 squared, or simply 4. So let's say we can simply put this as x equals 2, but as x approaches 2 means it goes from a certain point in the graph until it goes to 2. But so let's say we have this, it looks like this. So now, if we want to prove this, we would plug in x is 2, and then it would go up to here, to 4. My drawing isn't exactly to scale, so please bear with me. So as x approaches the value of 2, it lands on the y value of 4. So this is exactly what that means on the scale of that. Okay, now let's go with something harder. Now let's solve an actual problem, now that you understand what limits look like visually and how they behave visually. So let's say we have the limit as x approaches 5 of x squared minus 25 over x minus 5. So how can we solve this problem? We're already given the value of x approaches 5, which x approaches 5 of x squared minus 25 over x minus 5. Notice here that this denominator is a difference of perfect squares. So we can actually factor it with the difference of perfect squares. So in this case, it would be the limit as x approaches 5 of x minus 5 times x plus 5 over x minus 5. And I'm going to show you something really cool. Notice how you can cancel out the numerator and the denominator at the same time. That means these two will cancel out and divide into 1. So now we're left with the limit as x approaches 5 of x plus 5. Now that we simplified the algebraic expression, we can plug 5 into x. It would be 5 plus 5 is 10. So this is the final solution to this problem. Now I want to go over something easier or simpler for you, for all of you, as the sake of simplicity and exercise. So let's go over something once more. This time I want to go over a polynomial expression. So it would be the limit of x approaches 4 of, let's say, x squared minus 6x plus 7. You're probably wondering, what's the point of doing all this work when you can actually simplify it into two binomial expressions? You could do that. However, in this situation, it's easiest when and best when you can plug in x equals 4, as there are no additional operations needed. So with that being the case, it would be 4 squared minus 6 times 4 plus 7. So it would be 16 minus 24 plus 7. 16 minus 24, what's that? It's going to be negative 8. Sorry about that. So it's going to be negative 8 plus 7, and that's equal to negative 1. So this is what the limit of this parabolic equation symbolizes or goes through when it reaches its y value of negative 1. So thank you guys for watching this video, and keep posted for more examples.